Good morning. Welcome in lecture number 4. I hope you all are safe and healthy at your home. Some precautions for COVID-19, if possible, please follow. Gargle with hot water. Eat hot and healthy food. Drink hot milk with turmeric powder. Drink hot Ayurvedic kadha as much as possible, and alcohol, smoking, and tobacco chewing is to be avoided strictly. Thank you. Now we start our synthesis. In last lecture number 3, we synthesize antipyretic and analgesic drugs antipyrine, aminopyrine, and phenacetin. Remaining 4 we synthesize in this lecture. So, first of all, we start with paracetamol. Paracetamol is synthesized from phenol, and phenol is treated with nitrating mixture. Sulfuric acid and nitric acid, mixture of nitrating acid or mixed acid at low temperature give yield paranitrophenol or 4-nitrophenol. This paranitrophenol is treated with acid metal reduction Fe plus HCl. So paranitrophenol is converted into para-aminophenol. Now, this para-aminophenol is treated with acetic anhydride. Here, acetylation takes place. Acetylation. So, acetic anhydride, acetyl group is introduced and we get paracetamol. The final product paracetamol. Uses. It is a widely used antipyretic drug with some analgesic actions. Now, second component aspirin. It is also known as acetyl salicylic acid. It is synthesized from phenol. Phenol is treated with sodium hydroxide NaOH with high pressure. First of all, phenol is converted into sodium phenoxide and then at 120 degrees Celsius pass carbon dioxide CO2, then it is converted into sodium phenyl carbonate. It is noted that first phenol is converted into sodium phenoxide and then after sodium phenyl carbonate is obtained. Now, rearrangement of this sodium phenyl carbonate. We show here rearranged structure from COONA group from here and hydrogen from here are transferred and COONAOH, that is phenol orthocarboxylic acid. This phenol orthocarboxylic acid is treated with hydrochloric acid known as hydrolysis and we get salicylic acid as a product. Now, from salicylic acid, it is treated with acetic anhydride. In presence of sulfuric acid, we get our product aspirin or acetyl salicylic acid. Uses or application It is considered being the safest drug. It is used as an antipyretic, analgesic, and antirheumatic, usually in powder, capsule, suppository, or tablet form. It is converted onto calcium and aluminum salt to change its taste and side effect. There is some anesthetic action when applied orally. Aspirin is absorbed from gastrointestinal tract. The acid of the stomach causes a partial hydrolysis of the ester. The ester circulates in the blood and further hydrolysis occur. In that fluid to yield salicylic acid, which is the active component. This blocks or interferes with the pain impulse which are being transmitted to the thalamus and to raise the threshold of the pain stimuli. So it's all are its uses. Now aspirin's side effects. Aspirin causes several side effects. It may cause minute ulcer in the stomach and cause bleeding. It reduces blood viscosity. Some persons are allergic to aspirin. The usual allergic reaction is rash on skin, lowering of blood pressure, bronchial spasm, profuse sweating, intense thirst, nausea, and vomiting. These are the bad or side effect of aspirin. Now, third component, Salol or phenyl salicylate. Phenyl salicylate or Salol is synthesized by salicylic acid and phenol. These compounds are treated in presence of POCl3 phosphorus oxytrichloride at 120 degrees Celsius. At 120 degrees Celsius, salicylic acid and phenol is fastest converted into Salol. Now, application or uses of Salol. It is used as an antipyretic as well as internal and external antiseptic. When it is taken by patient, it passes unhydrolyzed in stomach but undergoes hydrolysis slowly in the intestine into two active fragments, salicylic acid and phenol. The biological hydrolysis of phenyl salicylate or Salol is so slow that its component of hydrolysis, that is phenol and salicylic acid, are released within the organisms in a very low concentration. Thus, only their analgesic and antipyretic effects show up while their toxic effects remain hidden. Salol is also used in case of diarrhea. And our last component, heptazone or Phenadoxane. Heptazone or Phenadoxane. Synthesis for heptazone, we have two starting materials. One is 1-chloro-2 morpholonopropane and second is diphenyl acetonitrile. In this synthesis, 1-chloro-2 morpholonopropane. Here some mistake, morpholono is not proper, morpholino. Morpholino. Here is not O, morpholinopropane. It is prepared by reacting 2-aminopropane 1-ol with di-2-chloroethyl ether. So interaction between 2-aminopropane 1-ol with di-2-chloroethyl ether is give 1-chloro-2-morpholinopropane, and this 1-chloro-2-morpholinopropane is reacted with diphenyl acetonitrile. Both reactant are react each other in presence of sodium amide NaNH2 and gives intermediate or derivative of morpholino product. This derivative of morpholino is treated with ethyl magnesium bromide salt, C2H5MgBr, which converted into heptazone. So finally, by interaction with 1-chloro-2 morpholinopropane, here mistake is corrected. 1-chloro-2 morpholinopropane and diphenyl acetonitrile are interact in presence of sodium amide gives derivative of morpholino, which is treated with ethyl magnesium bromide C2H5MgBr gives heptazone. And last, application of heptazone. It is an analgesic with morphine-like action but with minimum habit-forming nature. In last two lectures, lecture number 3 and 4, we complete our second group, antipyretic and analgesic drugs. In two lectures, we synthesize antipyrine, aminopyrine, phenacetin, paracetamol, aspirin, Salol, and Heptazone. And above first two lectures, we complete antimalarial drugs. In this group, we studied three components: chloroquine, primaquine, and chemoquine. And now, next lecture, we will study sulfa drugs or antibacterial drugs.